In this video, we're going to take a look at section 5.8, which is on variation. There are two main types of variation: direct variation and inverse variation. When a relationship is described as direct variation, what that means is that when one variable changes by a certain factor, the other variable will change by the same factor. So if we were to say that y varies directly as x, the formula to describe that relationship is given by y equals k times x. All right, so you'll want to memorize that. So when you see the word directly, you should immediately think of the formula y equals k times x. Now what's going to happen in a lot of these problems is they won't be using x and y, they'll be using different variables. You just swap them out. Right? So whatever the first variable is, you swap y out for that variable, and whatever the second variable is in your statement, you swap x out for that particular variable. And this will be what your formula looks like using whatever variables are given in your particular problem. Right? So if you double the value of x here, the y value also doubles. All right. For inverse variation, the relationship there is that if you are to change one variable by a certain factor, the other variable will change by the reciprocal of that factor. So if we are to double the x value here, it would cut the y value down in half. So that's the relationship between two variables that have inverse variation associating them. The phrase y, not equals, I don't know why I was going to say equals, y varies inversely as x can be described using the formula y equals k over x. All right, let me try that again. All right, so y equals k over x for varies inversely. So again, you want to memorize that. So when you see the word inversely, you should immediately think of the formula y equals k over x. Have that one memorized, and then you'll switch out the x and y for whatever variables happen to be given in your particular problem. These variation problems have up to 3 levels. So not every problem goes to all 3 levels, but they will progress through these same 3 levels. How do I want to say this? So some problems are only 2-level problems. Some of them just have the first level. But if you have a problem that reaches the 3rd level, it has to go through the 1st and 2nd level to get to that 3rd level. So all of these problems are going to have some amount of these steps involved. And so some problems will just be level 1 problems where you just construct a formula. So that's the first level. Some problems will reach level 2 where they ask you to find the value of the constant k, which I didn't really talk about what that was on the previous screen, so I might go back and talk about that. But in order to do level 2, you have to first accomplish level 1. So they'll have to give you information for level 1 so that you can advance to level 2 to be able to find the constant k. And then the 3rd level, the highest level that these problems will reach, is to ask you to answer a question. So they'll say, what is y equal to when x is equal to blank? And so you can answer that question, but only if you've gone through the first 2 levels, right? You have to construct the formula and find the constant k in order to be able to answer a question like that. And so that would be the most complicated type of this problem, going all the way to level 3. Now, k, which you saw in the formulas back here, and I didn't say anything about it, and I apologize, because you might have been thinking, well, there's x and y, but where does k come from? K is a constant, which means, let me redo that. All right. Which means it doesn't change, right? The word constant means not changing. Now, if you go from one problem to another, the value of the constant will change. But within a given problem, the value for k is fixed. It will not equal different numbers. It's just equal to one particular number. And it's our job to find out what that number has to be. And we have to be given some information to do that, which they will do. When they ask us to reach level 2 or level 3, there'll have to be some information there about how to find the constant k. We represent it with a letter because it's an unknown value, right? We don't know what k is equal to yet, but it's not the same thing as a variable, right? So even though it looks like it might be a variable, it's not a variable. X is also a letter, but x is a variable here, meaning even within the same problem, x can equal different numbers. Sometimes x might equal 1, and then we might have x equal to 2 next, and then we might try x equals 3. We can plug in different numbers for x, and we will get different answers for y. So y is also a variable because it can equal different things. But k does not equal different things. K is a fixed number. It will not change. All right, so once we find out what k is equal to, we take the k out of the formula. We replace it with the thing it equals, since it can't equal anything else. It can only equal that one particular number. All right, so that's what a constant is. So we represent constants and variables with letters, but there's a major difference between them. Variables can vary. Constants do not vary. They always equal the same number. All right, so let's just take a look at an example. All right, solve the problem. The weight W of an aluminum flatboat varies directly with the length L of the boat. If a 14-foot boat weighs 238 pounds, then what is the weight of a 10-foot boat? All right, so this problem is going all the way to level 3. I don't like some of the problems on the homework, they'll just have you do a level 1 problem and then a few of those, and then a few level 2 problems, and then they'll get to these level 3 problems. But I just want to go for the level 3 problems because it includes all of the steps that you need to know how to do. So the first sentence here is to help us figure out the formula. It's level 1. And I hate to say this, these are all going to be word problems like this. They all involve words and descriptions, but these aren't really as bad as the word problems we were doing in 5.6, in that these are pretty formulaic. They follow the same structure every single time. What you want to look for in these problems is this keyword, right? This says varies directly. And you memorize this. If it varies directly, the formula I immediately think of is y equals k times x. But in this problem, we're not using x and y as our variables. Instead of y, we're using w. So I'm going to replace the y variable here with the w. And instead of x, we're using L. So I'm going to swap those out. And this gives me the formula that I want to use in this particular problem. It exemplifies the varies directly relationship, and it's using the two variables that are suggested in this problem. They suggest using w for weight, L for length, and that's what we're using. So that's the first step. That's level 1, figuring out what the formula has to look like, right? It has to be w equals k times L, where k is our constant. Now, we can't answer any questions with this formula until we know what k is equal to. So that's the second level. That's the second step. Find out what the constant k is equal to. And that's what this next piece of information is for. So let me enumerate these. This is level 1 right here, the first sentence. This is level 2. If a 14-foot boat weighs 238 pounds, so they're giving me numbers to plug in for my two variables. We have the weight, which is 238, I plug that in for w, and we have, it's a 14-foot boat, that's the length, I plug that in for L. And I can plug those two numbers in to my two variables here, and then I can solve for k to find out what k is equal to. Right? So we're going to plug in 238 for w equals k times L, which is 14. And now I'm going to solve for k, and I'll find out what k is. Divide by 14 on both sides. I didn't learn my lesson earlier today when I was recording 5.6 to have a calculator handy, and I actually don't even have my cell phone handy at this point. So let me pause the video. I'll be right back with my cell phone so I can do this calculation. Okay, so I did the calculation, and this comes out to a nice even 17. So k is equal to 17. And again, that's a constant. K, for this particular problem, will never equal any other value than 17. And since it's not going to vary and equal different numbers at different times, there's no reason to leave k in the formula. It's just going to be, it's the number 17, and that's what it always will be. So we're going to plug it into our formula, and that gives me that w equals 17 times L. So that is our equation that we can now use to answer this question. So here's level 3. What is the weight of a 10-foot boat? So they're giving me the value for L, right? It's 10 foot, and I can find W by plugging that into the formula here. So let's just have some more space over here. Let's do level 3 over here. So L is equal to 10. We can plug that into this formula here. We'll plug in 10 for L, and we get that W is equal to 170. So that would be 170 pounds, right? Okay. And so that's how these variation problems all work. Let's take a look at another example. The time required to do a job varies inversely as the number of people working. It takes 7 hours for 9 bricklayers to build a park wall. How long will it take 6 bricklayers to complete the job? So again, this goes to all 3 levels. If it asks you a question like, find out how long like in this case, how long does it take for 6 bricklayers? It's asking a question for us to answer. That's level 3, which means we have to be able to do level 1 and level 2 here as well. So you go back through the problem and look for that information. And usually it's broken apart into pieces where it's pretty easy to see where the 3 levels are. This one's actually broken apart into separate sentences. So the first sentence is level 1. The time required varies inversely with the number of people. And then it takes 7 hours for 9 people to build the park wall. That's numbers for us to plug into our formula to find K. So that's level 2. That's the second sentence. And then level 3 is the question that they're asking us here. So there's the 3 levels. This time it varies inversely. So I immediately think of the formula y equals K over X. So if it varies inversely, that's the formula that describes that relationship. But we don't want to use X and Y in this problem, even though we could, because it doesn't actually provide us variables to use. We have to come up with our own variables. So we could continue to use X and Y, but it might be confusing which one's X, which one's Y. So I would recommend using letters that help you remember what they're representing. So here, the time, that's the variable over here on the left-hand side. I think we should use T to represent that variable. Varies inversely with the number of people. So we could use N for number, P for people. It's your choice. I think I'll just go ahead and use N this time. So N for number of people. Right? So instead of Y, we're going to use T. And instead of X, we have the variable N. And so this is our formula. This is level 1. We have our formula here. Level 2 is to find out what K is equal to in that formula. So we'll do that here. By plugging in, it takes 7 hours, that's the times, that's T, for 9 bricklayers. That's the number of people. So we'll plug that into this formula. For T, we're going to plug in 7 equals K over. For N, we're going to plug in 9. And then we're going to solve this for K. To get K by itself, we just multiply 9 to both sides. That cancels out the 9s. And so we'll get 63, right? 9 times 7 is 63 equals K. That's the value of the constant. It's not going to change, so we might as well replace the K in the formula with the number that it's always going to equal for this particular problem. And so we have T equals 63 over N. And that's level 2. Sorry, I already put the 2 up there. Guess I don't need to do that again. All right. So that's the result from level 2. Level 3 is how long will it take for 6 bricklayers? So that tells me N is equal to 6. So again, N is a variable, right? Here it was equal to 9, now it's equal to 6. T was equal to 7, now it's going to equal something else. But K does not change. It's always equal to 63. So that's why we go ahead and plug it in permanently. All right, so for level 3, we're going to plug in 6 for N, and it doesn't look like it divides nicely, but, well, it's not going to be a whole number, but actually, I think it's going to be like a 0.5, something 0.5, which isn't that bad. In fact, I think I can see what the answer is here. Without using a calculator, it's going to be 10.5. So not the worst answer, not the best answer, but not the worst answer either. So to take 10.5 hours for 6 people to complete the job, right? And that's what we plug in here. Round to 1 decimal place as needed. It came out to 1 decimal place, so we're good. All right. There's one other keyword for these variation problems that you need to know. And that is varies jointly. And this gets a little bit more complex. Varies jointly really means it varies directly with 2 variables instead of 1 variable. All right, so varies jointly as x and z. So if you see that phrase and you see the keyword varies jointly, this is the formula that would describe that relationship. Y equals k times x times z. So in this case, if you double either x or z, it doubles the value for y. If you double both x and z, it quadruples the value for y because doubling x makes y double, and then doubling z would make y double again. So it actually quadruple it, right? That's the relationship behind it. That's the mathematical connection there. But what you really need to know is if it varies jointly, you should know this formula. Y equals k times x times z. And then we swap out the x, y, and z for whatever's actually in our given problem. So let's take a look at an example of this, of varies jointly. Find an equation of variation. Now this one's not asking us a question. It just says find an equation, which means we're only going to level 2 on this problem. Find an equation of variation in which y varies jointly as x and z. So that's level 1. And in fact, for this one, we don't have to swap out variables. It's using the same exact variables that we have memorized in our definition. And then y equals 42 when x is equal to 7 and z is equal to 6. That's level 2. Numbers for us to plug in so we can solve for k. And then we'll find the constant and we'll put that in our equation and we'll have an equation. And it doesn't go on to ask us any questions. So this problem stops at level 2. Right, so level 1 varies jointly. I have memorized a formula for that. The formula is y equals k times x times z. And then I would swap out x, y, and z for whatever variables are in my problem, but those are the variables in my problem. So I'm just going to leave it the same. So this is it. That's level 1. That's my formula. Y equals kxz. Level 2, I'm going to take these numbers that they've provided, y equals 42 when x is 7 and z is 6, plug them into this formula here. So for y, we're going to plug in 42. For x, we're going to plug in 7. And for z, we're going to plug in 6. And this one works out kind of funny, it looks like. So 7 times 6, we're going to multiply those together and we get 42. And then we solve for k by dividing the 42 to the other side. And we get 1. All right, so k is equal to 1, which is okay. I mean, there's nothing wrong with that value for k. It's just that my final answer is not going to exhibit that very well because your final answer isn't, oh, plug in y equals kxz. It wants you to find the constant and put that in your equation. And that way, whatever you type into this box should have the constant plugged in for it. All right, so my final answer will be y equals 1 times x times z, because k is equal to 1 this time. And normally that number would just stay there. But 1 doesn't stay, right? If you multiply by 1 and you simplify it, 1 times xz is just going to be xz. Right? The 1's still there, it's just invisible, right? So you won't actually visually get to see it in your final answer. But that's our final answer here, and that's what we plug into the box. So you plug in xz. Be careful about this, because sometimes MathXL will have it there, sometimes it won't. So you have to really pay attention. It's already typed on the screen, y equals, so you don't want to type that part back into the box. I see students make this mistake occasionally. So they'll say, oh, the answer is y equals xz. They type in here, y equals xz, but they already had the y equals on the screen, so you don't need to type that in again. You just need to type in the xz to this box. All right, so that's how varies jointly works. And if they had asked us a question, that third level isn't really all that hard to do. You just take the numbers they give you, plug them in for the variables, and solve for y, and you'll have your answer there. All right, so I have a few more examples here, but I think this is a good time in the video for you to try out some of these problems first. So I'm going to go ahead and read the problem, and then I'm going to suggest that you would pause the video after I read it, see if you can piece together the answer, go through the 3 levels and get your solution, and then resume the video to see if you came up with the correct solution. So the weight W of an object varies inversely as the square of the... Okay. I hope you didn't pause the video yet. So we haven't done one quite like this. So I apologize. I jumped the gun a little bit. This one's a little different because it varies inversely as the square of the distance, right? So we have to take that into account when we are putting our formula together. So maybe let me do this one for you guys. And then I think the next couple of examples would be ones that you should be able to do first. All right. So the weight W of an object varies inversely. Now, when I see inversely, I immediately think of y equals k over x. I have that memorized. And when I see that keyword, this is the formula that immediately pops into my mind. Except instead of y, we have w, right? So we can just swap out the y for the w. But here's where it gets a little tricky. Instead of x, we don't just have d as our variable. We have to use the entire description here in place of x. And it isn't just d, it's the square of the distance d. So instead of x, we have the distance squared. So we have to make sure to take that into account when putting the formula together. So instead of x, we have d squared. So that's level 1. That's coming up with the formula. So make sure when you're creating these formulas that if there's extra descriptions with the variable, that becomes part of the formula as well. That's level 1. Level 2, at sea level, which is 3,978 miles from the center of the Earth, an astronaut weighs 124 pounds. So there's a couple numbers for us to plug in. The weight is 124 pounds. The distance from the center of the Earth is 3,978 miles. So we can plug those numbers into our variable. I'm going to do that over here. So in place of W, I'm plugging in 124 equals K over, now this number is going to get kind of big. The distance, which is 3,978 miles, which has to get squared, right? Because we're squaring that distance. And so now I can solve this for K. I will multiply the 3,978 squared to both sides of the equation. 3,978 squared. Multiplying it to both sides, that cancels it out from the right-hand side, so I get K by itself. And then this part I need to plug into my calculator. 3,978 squared times 124. So let me do that real quick since I have my calculator handy. So I have 3,978. Oops, I typed in the wrong number. 3,978 times 3,978. So I have an iPhone. It's an old iPhone, but and I know there's a square button on here, probably if I held it sideways. But another way you can square a number is just to multiply it to itself, right? So 3,978 times 3,978 times 124. And this is going to be big. Oh, it's maybe even just a little bit too big for this calculator. Okay, I'm going to have to hold it sideways anyway. So you really don't want to round this off. So because what my calculator did was e to the 9th power, which is scientific notation, which we talked about in a previous chapter. I think it was chapter 4. All right. And you don't want that, because if it's going into scientific notation, it's rounding some numbers off, and you don't want to round numbers off here. It's probably expecting an exact correct answer. I don't know. It says round to the nearest hundredth, but you want to keep as many decimal places as possible. So by tilting my phone sideways, I don't know, maybe your calculator might not be able to handle this big of a number. So it's 1962236 All right. So what is that? That is billion. So it's 1,962,236,000. It's a really big number, but that's the value for K. And try to keep it without rounding it off as much as you possibly can. If it forces your answer into scientific notation, that's fine. It should give you a precise enough answer, but keep all the decimal places that you can. All right. So this is my value for K. So let's go ahead and plug that into our formula right here. And so my equation becomes W equals this big number here, 196. I'll try to write this a little bit better for you to see. 2236016. Right? That's the value for K over D squared. Right? So that's my result from step 2 is this equation. And now I can use this equation to answer a question, which is exactly what it asked me to do. Find her weight when she is 421 miles above the surface of the Earth. Now you might think, okay, there's my distance, 421. But remember, the distance D is measured from the center of the Earth, not from above the surface of the Earth. So if this, so think about, okay, here's the center of the Earth, here's the surface of the Earth. The astronaut is above the surface of the Earth. So here's where the astronaut's located. So the distance from the center to the surface is 3,978 miles. That's the information given here to sea level, right? And then the astronaut's an extra 421 miles above that. So to get the astronaut's total distance from the center, we'll have to add these two numbers together, right? So let's go ahead and do that on our calculator real quick. So clear out that big number we had previously. 3,978 plus 421 gives me 4,399. All right. So the astronaut is a total distance of 4,399 miles from the center of the Earth. That's what we're going to use for the distance. So we're going to plug that in here for D, and then we can solve and find W. So I'm sorry, I was not very organized here. So let's do level 3 over here. We'll have W equals 196,223,6016. I barely can fit that. Over the distance, which is 4399, and then that has to get squared. And so I'm going to plug this in my calculator and hope that my calculator can actually handle all that information. All right, so we have 4399 times 4399. I might as well tilt it sideways because I'm going to have to do that anyways. And so I get, for the denominator, I'll have 19,351,201 when I square that. And so I want to take that answer and divide it, and take the big number divided by that answer. And I don't know if I can do that on my calculator or on my cell phone. Let's see. Does it remember numbers? It doesn't look like it does. I don't see like a previous answer button on here. And so I better just write that down so I don't forget it. Okay, so we're going to have 196,223,6016 divided by this big number here, which is 19,351,201. All right. And so now I'm going to divide these numbers. Hopefully I'll type them in correctly here. So we have, let's just do it like, well, now I have to keep it sideways. Okay, 196,223,6016 divided by 19,351,201. And so I'm coming up with what seems to be a reasonable answer. So keep that in mind, that your answer should be something reasonable with this. If the astronauts further out in space, they should weigh less than they would on the surface, right? So on the surface, the astronaut's 124 pounds. Being 421 miles above the surface, it looks like the astronaut would weigh 101 point, so slightly less. We went around to the nearest hundredth, which is 2 decimal places. So 0.40 looks like what we would get. And so I would keep the 0 there. You might say, do I have to keep that last 0? Numerically speaking, it doesn't matter. Like 101.4 is the same as 101.40. But you want to keep that 0 there to let people know that you measured it to that degree of accuracy. So you have it correct to the second decimal place. So you keep the 0 there as an indication of the precision of the number. So even though the value of it maybe doesn't matter if the 0 is there or not, the precision of it does matter. So keep the 0 there, and I would type in your answer as 101.40. All right, and that's how many pounds the astronaut would weigh 421 miles above the surface. So I apologize. I almost had you guys do that one without any guidance, and that one was a little more complicated, obviously because we had to square the distance, but also because the numbers are pretty ridiculous. All right, let's try this one. Okay, so this one looks a little bit more reasonable here. So let's read the problem together, then I'll have you pause the video, try the problem out first before you, see what the solution is. So find the variation constant and an equation of variation where y varies directly as x and y equals 0.7 when x is equal to 0.5. All right, this is just a 2-level problem. It doesn't go all the way to level 3 where you have to answer a question. So pause the video, see if you can figure out what the constant is, what the equation should look like, and then resume the video to see if you came up with the correct answers. All right, so I see that y is varying directly as x, so I immediately think of this formula, y equals k times x. I would swap out the x and the y for what variables are being used in the problem, but in this case, those are the variables being used in the problem. We want y, we want x, so we'll just leave it the way it is, the way we have it memorized, and that's level 1. So we have our formula. Now we'll move on to level 2, which is to plug these numbers in for x and y. So let's go ahead and do that now. For y, we're going to plug in 0.7. For x, we're going to plug in 0.5. And then we can solve for k to find out what k is equal to. All right. So we'll divide by 0.5 on both sides, and we'll get our value for k. So the 0.5 cancels out, and so k is equal to, and I'm sorry, I said the numbers were better here, but even though these aren't really ridiculously big numbers, these aren't the most pleasant numbers to deal with either. These don't divide nicely. They're decimals, and they become a fraction when we solve for k. And it's really frowned upon to have numbers that have decimals inside of fractions. So we really don't want to leave our answer like this. So if this is what you came up with, it's not wrong. That is the value for k, but it's not really in the best form. If you plug it into your calculator, you would get a decimal, but it doesn't want a decimal, right? It says type the answer as a fraction. So the first box here is asking, what's the constant equal to? It doesn't want the equation yet. It wants to know the constant. So this is where we're going to type in the value for k. And if you type this in, it's not going to count that right. If you plug it in your calculator, I think you're going to get 1.4, but I just want to double check that. So if you plug it in your calculator, you get 0.7 divided by 0.5, and you get 1.4. And if you type that into Math Excel, it's not going to count that as correct, because again, the directions are very explicit here. Type your answer as a fraction. This is not a fraction, it's a decimal. So how do I get this in fraction form? Well, some of you have calculators that will do that for you. You have the 1.4 in there, and you just convert it back to fraction form, and it'll give you the fraction. But here's another way you could do that by hand. And really what we're doing here is we're multiplying a 10 to the top and bottom of this fraction. But what that does is it moves the decimal place one time to the right. So a trick you can do with fractions is you can move decimal places as many times as you want, as long as you move it the same number on the top and on the bottom. So I'm going to move this decimal place to the right once, put it here, so I get 7. I'll move this decimal place to the right once, and I'll get 5. And so this gives me 7 over 5. Whoops, I almost wrote k, but I want to write equals to first. Okay, I don't know why it took so long to undo that. All right, and so we get the value for k is 7/5, which is the same thing as 1.4. All right, again, you can think of it as moving the decimal place the same number of times, or you can think of it as multiplying a 10 on both sides of the equation. Or not both sides, multiplying a 10 to the top and bottom of the fraction. So 10 times 0.7 gives me 7, 10 times 0.5 gives me 5. And that way we don't have decimals inside of fractions. So that's the value for k. That's what you want to type into this box here. And it's in fraction form just the way it wanted. And then the second part of this question is going to ask us to type in the equation. And here, students will make a mistake when they're taking my test and they say, oh, they want an equation. They'll type in y equals k times x as the equation. But that's the formula on which we're basing our equation. It becomes an equation, at least in my mind, I think of it this way. It becomes an equation when we plug in the value for k. And so that's not really the equation, right? Not with all the information that we now know. We know the value for k. It's not going to change. So don't leave the k in there, right? Replace it. So we're going to have y equals, in place of k, we're going to plug in 7/5. And then we'll have the x. And this is what Math Excel wants you to type in. So don't type it in as the formula. Type it in as the equation with k being plugged into that formula. All right. Okay. So I apologize for the difficulty of the numbers here. This is a pretty common theme for this topic. You're going to see this topic again in college algebra, except it's going to be a little bit more complicated with the formulas. And the other thing that they do in that course as well, when you cover this material, is they give you some difficult numbers to work with. Really big numbers, decimal numbers, square roots, things like that, just to kind of give you a hard time with the actual computation of the numbers. I don't know why, that's just a thing that they like to do with this topic. All right, so this is my last example. These numbers look a little bit better than they did on the last one. So again, I'm going to encourage you to pause the video, give this problem a try, see if you can come up with the answer, and then resume the video to see if you came up with the correct answer. Find the variation constant and an equation of variation. So again, just level 2. We're not being asked to answer a question here. Where y varies inversely as x. So again, being really nice about just keeping the variables the same as we remember the formula. So varies inversely, I immediately think of this formula, y equals k over x. And this time I don't have to switch out the x and y because x and y are the variables that I want to use in this problem. So this is my answer for level 1. This is the formula. Level 2, we'll plug in 3 for y, 19 for x. And I know those don't seem like very compatible numbers, but in this problem it works out just fine. The number will be a little bit big, but not too bad. So we're going to plug in 3 for y. We're going to plug in 19 for x. And then we're going to solve for k. And we'll do that by multiplying 19 to both sides of the equation to get k by itself, right? I'll cancel out the 19s. We'll get k is equal to 57, I believe is what that would be, right? Because 20 times 3 would be 60. We want one less 3 than that, so 57. So yeah, it doesn't work out very bad at all. So the constant, the variation constant is 57. That's what you would type into this box here. And then for the equation, you're going to type in y equals 57 over x, right? So you take your value for k, you plug it into your formula so that you get the equation that could answer questions if they had any for us, right? So again, don't type this in to Math Excel as your equation. Type this in with the information you found for k plugged into the formula. And also don't type this in. Now, this is the end of the video, but let me just say this real quick. Sometimes on the test, I'll get students where this is their answer for the equation, where they just leave all these numbers plugged in. You don't want to leave 3 plugged in for y. You don't want to leave 19 plugged in for x. Those are not constants. Those are variables. They will change value. They could ask us a question like, what is y going to equal when x is equal to 3 or something like that. They can change the value of x to a different number. And we want to be able to plug in different numbers here for x, not leave it as the number 19. So only k gets replaced permanently. The other letters go back to just being letters, right? We plug in numbers temporarily, solve it for k, and then we go back to having them as letters again because they vary and they will equal different things later on. All right, so that concludes the video on section 5.8 on variation.